one more. So you can also join, like you have joined, you can join Google Meet. You don't have network? Huh? Okay. So what? So you have website. Can you open the website? Like, no, we all have joined through Google Meet link. Since this you are joining, right? So this TV is not working, so that's why. So my screen. Okay, now you can see my screen, right? So what I was talking about, we saw all this. Now remove all means, let's suppose I have these three elements in this list. Now I want to remove two elements from the list. Which one to remove? I want to remove Bob and I want to remove Charlie. Okay. Now what should I do? In the array list, I will do dot remove all, and I have to pass array list to remove. So what it will do? Whatever elements are present in this array list to remove, it will remove all those elements from this array list. Okay. So now if we see, let's debug it. Before removal, before removing, what array list has three elements and array list to remove has two elements. Now, after I call remove all, array list will have only one element. The two elements which is present in array list to remove is removed. So that's the purpose of remove all. Contains all, it will return true if the list contain all of the elements in the specified collection. It means here, let's suppose if I say contains all. So what it will return? True or false? True. Very good. Because it contains all the elements which is present in this. Okay. So if we want to check, let's run this. Sorry, let's debug it. Here it is true because it contains all the elements. Okay. So that is the purpose of contains all. Contains we have seen. Now retain all. What it will do? Remove all will remove all the elements present in this list. Retain all will. What we have deleted. Very good. So it means that whatever we have mentioned in this list, it will retain all those elements and rest what it will do? Rest it will delete, na? See, array list, I am debugging it. At this array list, I have retained all. So it means array list will retain Bob and Charlie, which is mentioned in this list, and rest all it has removed. So that's the purpose of retain all. It will retain only the elements in the list that are contained in the specified collection. Okay. Set we have seen index of it returns the index of the first occurrence of the specified element. So if I call retain index of Alice, what it will return? Index of Alice, what it will return? 0, right? If I do index of Alice, it will return 0 because Alice is present at index 0. Last index of it will say returns the index of the last occurrence of the specified element. Let's suppose if I have Alice here. So now tell me what the last index of will return. In first place also we have in first place also we have Alex, and in third also. Now last index of will return. Tell me. Index of will return what? Index of will return Index of will return the first occurrence. What is the first occurrence? 0, right? Last occurrence is 2, right? Index is 2. First is index 0 and last is index 2. Last index. In sub-index, sub-list, what it will do? What sub-list will do? Let's suppose I want to get, I'm adding 5. Now I want to get a list which will only contain elements from index 1 to index 3. So what I will use? Sublist from index from Bob to Devansh. From index 1 to index 3 I want. So from index would be 1. And 2 index would be, it will be 4. It will be 4. Why? Because, just a second. Why it would be 4? Because it is exclusive. If you see, inclusive and 2 index is exclusive. It means it will pick elements from 1, 2 till 4 minus 1, 3. Okay, and I have to save it in some other list. Okay. So now if I run it, it will contain Bob, Allison, Devansh. Okay. From index 1 to index 3. Please note this index, what we mentioned is exclusive. Okay. So that was about all the methods of the list. List we have discussed, array list also we have discussed all the methods. Now we'll discuss about the linked list. Linked list, again, has become very slow, my system. There are two interfaces, list and DQ. It implements both the interfaces. It gives a doubly linked list data structure, which allows for efficient insertion and deletion of elements. So as we have discussed, each element, let me refresh it, it is very slow. Okay. So each element, it contains the reference to both the next and previous elements. We have seen, which will allow for bidirectional traversal. It can store duplicate elements and as well as null values. It is efficient for insertion and deletions. Let's take an example. When the most of the methods will be repeated. Why? Because both are implementing the same interface, right? So that's why you will find the common methods in both. Okay, now debug it. Now what we are creating an object of linked list class, which will contain data type as string. I'm adding 3 elements. Now, if I want to see Alice, Bob, and Charlie, it maintains the ordering. Okay. And dot add, what it will do? Dot add index 1 and dev, what it will do? Add index 1, that is after Alice. So it will add after dev after Alice. Add first. Now, anything? Okay. So add first. If you see, I am typecasting it. See. Before calling add first, I am using typecast to linked list. Why? Why I am typecasting it? Can you tell me? Because at first we have seen this method is not present in list interface. Add first method is not present in list interface. This add first is implemented by this class itself, by the linked list class itself. Okay, it is not the abstract method of the list interface. That's why you have to use typecast to access this add first. And why typecast? Why? Because you have stored or referred this linked list as list. You are storing in which reference? List of string. Yeah, anything you want to discuss? Like, you want to see here? You can tell me. You can see this now. Okay. So what I'm saying is, since see, you created an object of linked list and you are saving it in reference of list. List is the interface, right? In the reference of list, you are saving it. So it means using this linked list, you can only refer the methods which are present in list interface. Now, if you want to refer to the methods which are created by the linked list class, to use it, you have to first typecast it to the linked list class. Then only you will be able to use it. Or else what you can do here, you can save it into a linked list reference that you have studied while studying about the typecast and reference and all, right? So, but the practical usage here, since here if you use list, you will be able to access the methods of list interface. If you want to access the methods of the class which it has implemented, you have to use the reference of that class. Okay. Now add first is defined in this class. So now what add first will do? It will add to with the name. What does it suggest? Where will it add? At the first before Alice. See, before Alice, it will add Eve. Add last, what it will do? It will add after Charlie at the last. See, after Charlie, it will add to the last. Linked list dot get to what it will give? It will give dead. Get first, what it will give? Quickly. And get last, what it will give? Friend. And set. If I want to set Grace at index 2, which will be replaced? Date. And remove one, it will remove which element? Just remove. Now remove first. See, remove first. Why I have typecasted? Because these all are the linked list methods. Okay. Remove first will remove which element? Quickly. Eve, and remove last will remove. Great. Eve and Frank. Size is dot contains Alice will return. Huh? Come on. Dot contains Alice will return. False na? Speak fast. Clear will. Now I am adding it. Iterator, again, we have seen it to iterate the linked list. It will print all three. List iter, again, it will be to iterate this list. List iter index 1, it will iterate starting from index 1, no? Index 1. To array will convert, will give us an object array, which will have an element of type string. And here we are printing it. So these were about the linked list. That's how we access it. Okay. So here I have explained that casting, why casting is necessary, because some of the methods used are specific to the linked list class and not available in the list interface. So even though we have covered in previous, but I keep on adding the notes here because so that it will help you in revising at one place. So when you declare a variable as list, it only has access to the methods defined in the list interface. To use methods that are specific to linked list, you need to cast the variable to linked list. And if you want to avoid the casting, you just store in the linked list reference rather than list. It's very slow. I'll not use this vector. Vector, again, we have studied what is this? It is same as array list, but it is synchronized, making thread safe. So it will make it slower. Why? Because only one thread at a time can access their method. It is also backed by a dynamically resizable array. It is a fast random access in a single operation. It can access the elements where we can store duplicates and null values. So even though most of the methods will be same, and still go through these methods. Okay. Just quickly tell me, we are creating an object. Where it is. Okay. So how many elements we have added? 3. So Alice, Bob, Charlie. Vector dot add index 1. I want to add Dave. Now where it will be added between Alice and Bob, it is added. Add element Eve will what, where it will add? It will add after. Huh? After? Come on, after add element will add after Charlie. Simple. At the last, simple. Dot get 2 will return. First element will return and last element will return quickly. First and last will return. Set index to what it will do? It will. So it will replace or it will add? Add. So if it has to add, then I will just use add now. Set means it will replace this element of second index with Grace. It will replace which element? It will replace Bob. And set element at is same as set, where you also specify index at the last. It will replace which one? Grace with Hannah. Remove one will remove Dave. Remove element add will remove. Huh? I am providing 2. Charlie, na? Size will give me 3. Does it contain Alice? True or false? True. Clear will make it empty. Now I am again adding it. Iterator we use to iterate it. List iter again, it is used to iterate it. So see, while iteration, I am getting Alice, Bob, and Charlie. Now, list iterator, I am passing 1. Now, what will be printed here? Huh? Very good. Bob and Charlie. Bob and Charlie. Array will print what? It will print Alice, Bob, and Charlie, right? Why Bob and Charlie? It will print all three. Okay. Stack, it is again extended by a vector class, and it implements the last in and first out. So since it implement last in first out, so it should expose some additional methods other than present in the list. Since we have seen all of the classes are implementing its own specific methods. So stack, what method we should have? First is to push the element. An element is pushed to the stack on the top or bottom? On the top, and we pick pop element from the top. So that's why whichever is the last one, it will pick the first. So that is pushed last is the first one to be popped. So stack class inherits all the properties and methods of vector, which means it is also synchronized and thread safe. We'll again see an example of stack. It will contain a methods which are specific to stack. Okay. Now, considering the first element will be at the top, you have to tell me at this point. Yeah. Okay. I'm pushing Alice, I'm pushing Bob, and I'm pushing Charlie. Now, what will be the order of elements? Alice, Bob, and Charlie? Think? No one is there. I just. What do you think? Come on. Alice, Bob, and Charlie. See, what push is doing? It is pushing an element. So when you will view it, it will give you an ordered view. Since it is a list, it will give you an ordered view. Now, I am popping it. Now you have to pop it. Now, which one should come if you pop it? Very good. Now you will get a Charlie. See, ordering is not changed, but it has provided you an additional method so that it will pop in, it will give you a last one pushed element. Okay. Now, if you pop it, it means it will remove that element. Pop means it will remove and return that element, and peek means it will just return that element. It will not remove it from the stack. So if I pick it, peek, what should come? Bob, and it will not remove the Bob. Search. What search will do? It will search for an Alice, and it will give its position. So what will be the position of Alice? Position is 2. It is not returning index. It is returning position. So since Alice was entered the first, its position is last, which means 2 is empty. Means it empties the. Is stack empty? No. It will return true or false, depending if stack is empty or not. Adding elements at a specific position. It will end at a specific position, just like list it adds, right? Now Alice, Dave, and Bob is there. Now get an index 2 will return Bob. So you know position is different. Earlier, when we got the position of Alice, what did it give? 2. But the index 2 is present for Bob. So position and index is different. Size is 3. Contains same as list. Remove index 1. So see, whatever the methods which are of list, they will behave same as list. Rest other methods like poll, peek, and all, they will behave as relative to the stack. Okay. Like position. Is position present in list interface? Is position method present in list interface? No, right? We have not studied position. We only studied it in the stack. So position gives the position of element in the stack. Remove will remove from index 1. Clear will clear all the stack. Iterator will iterate through the stack. Alice, Bob, and Charlie. So see, we are iterating. It will always iterate from index 0. It is not iterating from the top, right? It is only be achievable through the methods. What are the methods to get the top element? Pop. It will remove as well as it will return. Peek will just return. It will not remove the top element. Push will add the element to the top. In terms of stack, it will add the element to the top. But if we do add, it will add to the last element, not at the top. Okay. So this was about the list interface, different implementation classes of list interface. Now let's do about the set interface. Just let me close it. Working fine now. So see how the half 90% of our computer problems it solves by restart. Once you restart the things, 99% problem will be solved. No one knows what has happened, what are the problems and all. We just restart it. So the set interface. What's the use of set interface? Or to avoid the duplicate. It avoids the duplicate. So the set can contain at most one null element, but list can contain lots of null elements. So see the set, what all method does it have? First, we'll study about the implementation classes, and there we'll study the common methods of set. So what are the implementation classes? Hash set, linked hash set, and tree set. So hash set is backed by a hash table data structure. So it does not maintain any order of elements. Was there the order of elements maintained in list? Ordering was there in the list, right? But in the hash set, there is no ordering. So the iteration order is not guaranteed. Okay. It provides constant time performance for addition, remove, and contains. What constant time means? Let's suppose in a single operation, it will search, it will add an element, it will remove an element. When should you use it? We should use it when you require that unique elements should be present without caring about the insertion order. Okay. Now there is another linked hash set. Linked means linked list we have studied plus hash set. It extends hash set class and it maintains a doubly linked list for all the elements. So since it maintains keep a doubly linked list, it maintains the insertion order of elements. So the order in which you have inserted the elements, it will maintain that order and you will get that order. And if you iterate through elements, you will get an elements in the order they were inserted. The performance is slower because it has to maintain the linked list. And in the linked list, how do we traverse? Using address. Very good. Each element will contain the address of its next element. And when should we use it? When the first use case is uniqueness of an element should be required. And also you want order of insertion to be preserved. Okay. Now tree set. Tree set, it implements navigable set interface. It is backed by red-black tree or self-balancing binary search tree. I think, have you read about this in your data structures? No, you can avoid it. It's fine. But what you can consider, tree set is used. First, it will contain unique elements and it maintains the element in a sorted order. Got it? It will maintain the elements in a sorted order. It does not allow null elements. Okay. When should we use it? We should use it first. The uniqueness should be there. We should need the unique element to be present as well as we need a sorted elements. Okay. Now we'll study about hash set. Hash set is implemented using a hash table. Hash table, it does not allow duplicate elements. And adding a duplicate element does not change the set. So let's suppose if an element is already added, if you again add it, it will not change the set. It will just discard that operation. If you want to add a duplicate element, it does not maintain any order of elements. So now let's cover the method through an example. Here you are creating an object, and which data type will be stored here? String. You are adding 3 elements. So the hash set will look like this: Bob, Alice, and Charlie. So have you noticed in when we were using array list and all, the order was maintained. When we were printing the list, what was the first entry which was coming? Alice, right? Like which was first inserted? Alice, Bob, and then Charlie. But here, first Bob is coming, then Alice and Charlie. It means it is not preserving any order of insertion. Okay, that we have verified. Now, hashset.add. Add is used to add an element. Will it add an Alice? Will it add Alice? No, because Alice is already there. So it will return false because the element is not added. Now I am creating another set. Now what add all will do? In this hash set, it will add all the elements which are present in another set. So it means it will add Dave and Eve to this hash set. So Dave and Eve is also added. What remove Bob will do? It will remove. Simple. It will remove Bob, na? So it will remove Bob from this hash set. So now Bob is removed. Now remove all another set. What it will do? Very good. It will remove all the elements which are present in another set. So another set contains 2 elements, Dev and Eve. So it will remove all the elements. So it will remove Dev and Eve from the hash set if they contain. If they don't contain, they won't be removed because they do not contain. So see, they have removed Dev and Eve. Now hash set dot contains Charlie. Will it return true or false? True. Is empty true or false? False. Size is 1, 2, na? How do you iterate? You get an iterator from the method called dot iterator, and then using has next and next, you iterate through each of the elements. Okay. So it will print Alice and Charlie. To array will what it will do? Object array. It will create an object array, and each element of an object array will be of type string. So if we print it, it is Alice and Charlie in an object array. Clear will remove all the elements. Okay. So what all methods did we see here? What add will do? It will add. If the element is already added, then false. Very good. Add all will. It will add all the elements which you have specified in the argument. Remove will. It will remove that object. Remove all mean it will remove all the elements which are present in the collection. Clear will contains. It will return true if contains all. Will return true if it will. Very good. Yes. So in the collection that you will pass, if all the elements which are present in this collection are present in the set, it will return true. Size will give you the size. Is empty will true or false. Retain all will no. So whatever elements you have provided here, it will retain all those elements, and rest it will delete. To array we have seen. For each we'll see like what does for each will do. Let's there is no index. There is no ordering. See, we have seen now. We were adding Alice and all. There is no order. There is no index. So that's why when you use get, were you using any index? See what I'm saying? There is no index, right? What you have to get an element? What do you have? How do you get an element? By what? How do you get an element? Very good. Because there is no ordering, there is no index. So what's the way to get an element using? Okay, that was for the hash set. Now linked hash set we have seen as a head table, as a hash table, where we will now maintain the insertion order. It does not allow duplicate elements, that is for sure. And if you try to add a duplicate element, it will not change the set. So it maintains the order of insertion of elements, and elements are returned in the order they were inserted. It only allows single null element. Okay. Again, we are creating an object, add will, add it. Now, after adding it, now when I will print linked hash set, will there be any order of the print? Will it, will there be any order? Yes, what will be the order? Very good. Alice, Bob, and Charlie, because we have seen it is maintaining the insertion order. Dot add will it add this? No, it will return false because it is duplicate. We are adding another set. Add all will again do the same. It will add all the elements which are present in another set. If this set already, if the linked hash set already contains dev, then it won't add that dev. It will add the remove will remove the bob. So see, we are not using any index. We are directly removing the bob. Remove all will remove all the elements which is present in another set. What elements are present there? Dev and Eve. So it will remove Dev and Eve from this. Contains will search if the element is there. Okay. Charlie is there? Yes. Is empty? It will return false. Size will give you a size through iterator. You can iterate through a set. It will give you two elements. To array, we know it will convert, and clear will remove all the elements. Okay. So now tree set. What are the features of tree set that we discussed? The first feature would be common, na? Huh? Simple. The first feature, it is a set, right? As soon as you hear set, it won't allow duplicates. What does it do? It maintains the elements in a sorted order. Linked hash set, what it was doing, it was maintaining the elements in a insertion order, and it is maintaining elements in a sorted order. How do we specify the sorting for a class? Using, that's a method to sort. How do we specify it? Like a student class, age, and name is there. I want to sort it by age or name. What do we use? Name it. Starting with C. What do we use? One interface is there. Huh? Yes. Comparable comparator. Great. That's the use. creating a tree set. Okay, I'm inserting Bob, Alice, and Charlie. What it will print? The order would be, huh? Simple. Alice, Bob, and Charlie, because it has sorted. And since string are by default, natural sorting is based on alphabets lexicographically. If we want to change any natural ordering of a class, what do we implement? Comparable interface, and we override a method. Duplicate again, it will return false. Another set, what it is doing, adding all the elements, and if you print it, they all are in a printed. Remove will remove it. Remove all will remove all the elements. Contains Charlie will return true. Is empty, true or false? Size is 2. Iterator will again iterate through each of the element and it will print it. To array will convert it into an object array of type string. Alice and Charlie. Clear will clear the elements. So what's the unique thing? It is maintaining the sorting order. If we want to store here any class, like in the head set, we can store some class also, right? Student also we can add. Yes or no? See here, we have taken an example of comparable. We have override compare to, and how we were comparing based on age. Yes or no? Right? Now I want to store a student object here, S1. What should I give? Name Rahul. Age is 20. Raman, age is 28. Amar, age is 18. Amar, age is 19. Okay, now I am adding these here. Where I remove all this code. Okay, now I have added this. S1 I have not added. Okay. I have added all these. Now tell me which object will come first. Then S2. Let's see. 18 and Amar, 19 and Amar, then 20 and Rahul, and 28 and Love. So it is automatically arranging in a sorted order. And how it identified the sorting algorithm? Using this comparable. We have implemented this comparable and then we have overridden which method? Compare to method. Okay. These are very good concepts, like you have to revise it, just revise it, run the code and all. You will be at a very good place in terms of knowledge. And then is the map interface. Map is a very widely used. It has some advanced concepts also, but we'll cover. It's fine. Map, it represents a collection of key value pairs where key is associated with exactly one key. Can there be duplicate keys? No, there can only be unique keys, and with each key there can be one value. Can there be duplicate values? Yes, very good. Values can be duplicate. A map can have null values, but only one null key. Null values it can have, but null key it can have only null value. This we'll see along with the implementation classes. So what are the implementation classes? One is hash map. is using hash table. It does not maintain any order of keys or values insertion, any sorting. It doesn't maintain any order. Order can change. It allows one null key and multiple null values. And see, it is very efficient to get and add the elements. It is done in single operation, O1. O1 time complexity means it is done in single operation, right? Because if you see in the list, the get was in single operation, but addition was taking ON. Yes or no? Access was in single operation, right? But when we wanted to add it, we have to do multiple things. And in case of linked list, the access was ON, but the addition insertion was one operation. But here in the hash map, the access as well as the addition and all is in single operation. That's why it is very much used. It is not thread safe. And if multiple threads concurrently modify it, it will throw an exception. One is hash map. Linked hash map means linked list will be there. It extends hash map and it maintains a doublet linked list across all entries. So linked list means it will maintain the order. It maintains insertion order depending on the constructor use. It allows one null key and multiple null values. Performance is same, but it will the impact would be there due to overhead of maintaining the linked list. The iteration through linked list is faster than iterating through hash map. Why? Because in the linked list we are maintaining the address. That's why iteration is little faster. Tree map, what unique feature it will have? Tree map means tree set. What tree set provided? That was for all the set. What was the difference between tree set? Very good. And what about linked? Was about maintaining the order of insertion, and tree was about sorting. So just remember this. Hash map means no order, no sorting. When you see linked, it means order of insertion. And when you see tree, it means sorting of the keys. It is implemented as red black tree, but since you are not aware of, you can avoid it. It maintains natural ordering means sorting of keys, and we can customize it using a comparator. It does not allow null keys because sorting is not possible for the null keys. That's why any tree set, tree map, it does not allow null values keys. It offers O of log n, time complexity for most operations. Why log of n here? Because it is maintaining the sort, and sorting is always takes time. That's why it is log of n. Now concurrent hash map. If the concurrent comes, it means it is a thread safe. Concurrent threads, multiple threads can access this concurrent hash map object safely. So it is also implemented using a hash table like hash map, but it is thread safe. It is designed for high concurrency. I think few classes back, someone was asking about thread safety and all. So that this is the one, hash map and concurrent hash map. If you want a thread safety, multiple threads is accessing the same object, you have to keep it concurrent hash map rather than hash map. Now we were studying a lot about hash table and all, right? So what is this hash table? So see, is this hash map and all these are using a hash table. So hash table, although you read it in data structure, but since you have not read it, we'll discuss it briefly. It is a data structure which is used to insert, get the data, access the data, remove the data and all. So it works on key value pairs. So there will be some key and corresponding it, there will be some value. Okay. And now, how does it store the keys? How does it store it? Okay. So let's take an example. See, let's suppose you have 10 students and you have 5 rooms. Student 1, student 2, student 3, student 4, student 6. Now you have room 1, room 2, room 3. You have 3 rooms and you have 6 students. You have to equally make the student seats in every room. So each room will have how many students? 2. Now, if I ask you, how will you assign an student to a room? How will you do it? And student can grow. Sometimes another student can also come, a new student can also join. So what will you do? Very good. What she's saying is first come, first serve. I'll first assign student 1 in room 1, then student 2 in room 2, then student 3 in room 3, then student 4 in room 1, student 5 in room 2, and student 6 is room 3. That is, we call it round robin, that you assign a student. But in terms of computer language, we cannot have a round robin because we don't know how many will be the items and objects to be insert and all, what will be the memory available to it. Let's suppose it is room 1, room 2, room 3. In the first round robin, you have an information saying okay, there are 3 rooms. Now let's suppose if a room is deleted or a room is added, then you won't be utilizing a room 4 and room 5, right? Because you just know about room 3. You are just assigning between room 3. So since memory, it allocates, it deallocates, sometimes more memory is available, sometimes less memory is available. So it doesn't make sense to do it. Okay. Now, what Java is doing is, it is, or any mathematical or any other program, what it's doing it is using a hashing function. If you have heard of. What hashing do is, so see, student 1, in terms of Java, student 1 will be an object. Object will have a fields, methods and all, right? So how do you represent an object? So what is it done? It gets a fields and then it calculates a hash of this object. And what this hash is, it is some integer, some random, some integer which is created based on the fields of an object. It means if there are same object with same fields, their hash will be same. You have to keep this in mind. Let's suppose if the same student comes, you can't assign a different room to that student because it is same. So it means if the object is same, the hashing function will return a same hash code. Now this hash code, this integer, is used to assign a value, a memory to this key value pair. Because if you use object, let's suppose student 1 object, you will be assigning some value to this object, right? And if there is a value, there will always be a memory, some address to this student 1. Okay, the student 1 comes, you will assign some memory address and then you will assign its value. Now tell me, how do you, now let's suppose I want to get a value of this student 1. How will I get this value? Very good. Great. You will call a hash function, which will give me a hash code. And based on this hash code, I can get a memory address and I can get a value. So that's why it's a single operation. Why? Because I'll get one object, I'll quickly create a hash code, and in a single operation, I'll get its memory and the value. So that is all the crux about a hash map, how the value are stored and all. Okay. Just a second. Okay. So hash table is a data structure that we have studied. It operates on the hashing concept, where each key is translated by a hash function into an index, then an array. The index functions as a storage location for the value. Hashing we have studied. It is a process used to map data of arbitrary size to a fixed size values, because there may be a limited memory. So if there are unlimited objects, then it has to take care of assigning the objects to a particular memory. hash function, again, it will be a mathematical function that takes an input or key, and then it returns a fixed size integer hash code. Okay. And now in the Java, you will find a hash code method. So it's a very important question in terms of hash map. So see, hash code method is used to store an key and value pair. And this key can be a student object also, a string, integer, it could be anything. So now what hash map says, there can be only one key. Okay. Can there be duplicate keys? No, there can be one key. If I am passing student 1 in the hash map and student 2, so how many keys will be there? 2. But if I pass the same object, then only one key should be there. Now, who will tell the hashing function that both of the objects are same? Who will tell? Key is the object itself. I should have some method which I can call on the object, which will tell me कि these are the same object, and what that method is? Hash code. So if the objects are same, so the hash code is an instance method. If for the same objects, the hash code will return same value. That's how the hash map function will decide कि okay, these two objects are same, whether to add it or not. Along with the hash code, there is also a method called equals. What's the use of equals? To find out if two objects are equal or not. So if the hash code is same, it means if I call equals method on those objects, it should also return true. So always keep in mind, if you override hash code or hash code, you should override equals also. That's a very important common interview question. Okay. So hash code is used to generate hash code for objects. And this method is inherited from the object class, and it should be overridden in a custom class to provide meaningful hash codes. Okay. So in hash map and hash set, hash codes are used to determine the bucket where elements are stored based on their keys. When retrieving an element, hash code helps in quickly locating the bucket. And then we compare the actual buckets using equals to handle the collision. Now, you will ask, what is collision? So see, in terms of in memory, right? In memory, we have some in RAM. Let's suppose there is a memory. We have some addresses. Address 1, 1 byte, then address 2, then address 3. Like this, we'll have multiple addresses. Okay. CPU will have, or OS will have information ki, okay, it has a 1000 bytes address. Okay. It has a addresses to store how many bytes? 1000 bytes. It will name it location 1. It means location 1 has 1000 bytes. Now it will name location 2, which will have next 1000 bytes, and it will have address for all the 1000 bytes like this. Then it will have location 3 for next 1000, 2000, or any bytes. Okay. Now, when I ask Java to store an object of size 100 bytes. Java is asking OS कि I have an object in hash map. It is of size 100 bytes, store it. Okay. Now, in this location 1, how many objects of 100 bytes can be stored? 1000 to 10, na? 10 objects can be stored, right? If one object is of 100 bytes, 10 objects can be stored. And this location 1, you can denote is some identifier or an index. Okay, through which it can get to this location. Okay, now how hash map will function is, it will get an object, it will call a hash code. What hash code will return? Some integer, and this integer will give us this location, index, this location index. Getting it? These we call it a bucket. Okay. Now tell me, in a single bucket, how many key value pairs can we present? How many objects can we present? 10. It means in a single bucket, I can have 10 objects. Okay. Now, if I want to access value of one object, what should I do? Huh? Now, I just have this location. I have 10 objects in this. I got this index, right? How I got this index? Using hash code. I got this index. Now here 10 objects are stored. Now how to get one of the objects from this 10 objects? I will iterate through all 10 objects. Then what will I do? I will search whether the object that I got is equals to the object that I want. If it returns true, then I will return that value. Are you getting it? Did you understand what's the purpose of hash code? It will provide us a bucket which contains multiple key values pair, and then to get one our desired key value pair, what we will use, which method? Equals method. So that's why it is important to override both hash code and equals method. Got it? So that's why in hash map and hash set, whenever you are using hash map and hash set for the custom objects, you always override equals and hash code. And you have to take care while implementing this that the equal objects in your terms, whatever the equal objects are, they should have equal hash, like they should return same hash code and their equals will should return true. So in terms of student object, like for example, let's take an example of student. In the student, right? In case of student, if there are two objects, let's suppose if I create two objects, Alice and same age, can we consider these two students as same? We can consider it, right? According to our logic, whoever student has same name and same age, they are same. But since here we are creating using new, all those will be created new. There will be two memories, right? But in while storing these two in a hash map, only one will be stored, because for us, these both are a same student. So when we will calculate a hash code for this student, I'm not sure if I have done it. No, I have not done it, but I'll do it. If I'll create a hash code, I should make sure that the same student will get the same hash code and equal should return true. Okay, that was about the hash code. Hashing collision, it occurs when two different keys hash to the same bucket that we have seen. So hash codes are integers, but there are limited number of possible hash codes, right? And most hash table implementations use chaining. Chaining means in a single bucket, there will be multiple objects, and we use equals to get the desired object. Okay. Now studied about the hash map. Hash map is implemented using a hash table data structure. It allows one null key and multiple null values. It uses a hash function to convert the key into an index, right? And then this index is used to store and retrieve the value. Whenever there is a collision, it uses a chaining. Okay. Yeah. Very good. So she's saying, like, you are saying that it is O of 1, but a bucket can have multiple objects. Then why are you saying it is O of 1? But see, in the computation, right, all these are very negligible. Why? Because if we keep on maintaining the index for each every address, it will again occupy a memory. It doesn't make sense to keep note of each and every memory, right? That's why we keep a location. And to keep a predefined amount, to keep a predefined objects into a memory, it is not counted as a high time, because traversing 10 or 100 as compared to millions of buckets is negligible. So we'll treat it as a single operation itself. So we when you read about data structure, we usually avoid or we ignore all these constant. That's why we call constant time. We ignore all this 5, 10, this constant number. This bucket would be very huge in size as compared to the number of buckets. All these all the objects that is stored in one bucket will be very negligible. And to use a custom class as a key in hash map, it should override the equals and hash code methods. So we'll quickly see the implementation using the student class. See what I'm doing. Why it is failing? Because the reference is incorrect. Okay. Now see what I'm doing, creating a hash map, and in the key, 15 बोलो मैसेज किया ना okay. So now in the hash map as a key value pair, what I am storing as a key, what I want to store it as store as a key, in this in this hash map, what I want to store as a key, student is a class. Earlier in this example, I am storing a string, but here I am storing a class. So each key will be a student object. Okay. Now, if I use any custom class, what should we have to do? We have to override equals and hash code method. Okay. Now, our equality of this object is dependent on which factor? Name and ID. So here in the hash code, what I am doing, I am calling the hash function, and this hash function should consider name and ID. It means if the name and ID is same, then it will return same hash code. And in the equals, what should I do? In the equals, what should I do? Come on, I should check for the equality of name and age, right? Right, my equality is dependent on name. If two objects has same age and same name, it means two objects are equals. So what I am doing here, if the reference is same, if the reference same anyway, these are the same object, we have to return true. If one of them is null and the class is different, we have to return false. And see what I am doing. I got a student one, and then ID. ID means current object ID should match with the past student object ID, and the name, the string name should also be equal. If both are equal, then equal should return true. Okay, that's what we have done. Now let's see an example. Here in the first example, I'm creating a hash map where key is a string and value is integer. What put will do? It will add the key value pairs. Key is Alice and value is 30. See, what put will do? It will associate the value with the specified key. And if the map already contain a mapping for the key, then the old value is replaced by the new one. Okay, that's what put will do. So see, after putting 3 entries, the map will show us 3 entries. Okay, I'm not able to see Charlie. Then one is key is Bob, value is 25, then Alice, then 30, value is this. Okay. Now map.get Alice will give me what? Not true. It should give me a value of that key. Get, if you use get and pass the key, it returns the value which is associated with that key. If there is no key present, then it will return null. So get Alice will return 30. Okay, it will return 30. Now dot contains key, what it search for, whether the key is present or not in the hash map. Contains key Bob will return true. Remove Charlie, what it will do? It will remove that key from the map. So it will remove this Charlie and what? Now it will have just Bob and Alice. Now iteration means traversing the each hash map. So what function do we use? We use entry set. So once you call the entry set, what it will return? It will return this function map.entry string integer. What it is returning? A key value pair. Because keys of type string and values of type integer. It is an entry, it denotes a key value pair. So the map.entry denotes a key value pair. We get it using entry set and then we print each key. So what get key will do? It will provide a key and then it will provide its value. So if we print it, see, Bob is the key value, then Alice and then value. What clear will do? It will remove all the elements. Okay. It will remove all the elements. Okay. Now, what we are doing here, we are creating a hash map of where key is a student object and value is a string. Okay. We have created 2. Now we have put it 2 values. Now student map contains key as an object whose ID is this, name is Alice, and its value is key's value is math. Now how to get the value using get. If I use get, I will get the value as string and then I will get value as math. Okay, did you get it? Size we have written. What is empty will give us whether the map is empty or not. Put all will copy all of the mappings to this map. So let's suppose if I create this. Put all copy. What it will do? It will add wonder to the map. Okay. Now map will also have wonder. Okay. Now contains value, it will check for the values. Contains key was checking for the key, but contains value will check for the value. If I check, so see, value is 25. Here, what I'm checking, map dot contains value. Let's suppose if I check for 30, will it return true or false? True. If I check for 500, it will return false. Okay. Key set, what key set will return? It will returning a set of the all the keys present. So if I do key set, it will return me a key set with all the keys. Why it is set? Because keys are unique. Keys are unique. That's why it is returning a set. Okay. And collection and values. What values will return? The collection of all the values, and we have to store in the type of collection. Here we have to store in the type of set, and here in the collection what we can use, linked list or anything. So map dot values, it will give me an all the values. Okay, it is giving me all the values which is of type integer object. Okay, and get or default, what does it do? So see, if I am getting map dot get Rahul 123, is Rahul 123 present in this map? It will return null. It will return null. But what I want, if the value is not present, you provide me some default value. Let's suppose if this is not present, give me some value 100, not null. So I will call this get or which function I will call? Get or default. So since value is not present, it is giving me an integer value 100. So that was all about the hash map. And rest we'll quickly cover. Linked hash map. It is implemented as a hash table with each entry. It maintains a link to the both next and previous entries. Here the insertion order is maintained. In the hash map, there was no insertion order. If you would have seen while printing it, there was no insertion order, but here you will find the insertion order. So iteration over entries is faster because we are maintaining the address. It is not thread safe. If we want to use a thread safe, we have to use collections.synchronized map, which will give us a thread safe map. And if you want to use a custom class, you have to override the equals and hash code methods that we have already seen. Let's quickly run its method. Link. Now what I am doing, linked hash map. What's the quality here? What it will maintain? The insertion order. Okay. So let's suppose I'm putting Alice, Bob, and Charlie. So the order that it should be displayed should be first Alice, then Bob, and then Charlie. Get will give me the value, same as hash map. Dot contains key, it will check if the key is present or not, same as the hash map. Remove will remove that key. Entry set again to iterate through the map and get all the key value pairs. What clear will do? It will clear all the values. And here we have using employee where it has stored name and ID, and it has here we are overriding the hash code and equals method, same as hash map. It's just that it is restoring or it is maintaining the insertion order. That's the difference between linked hash map and the hash map. The next is tree map. Again, we have studied it is implemented the red black tree, and here what is the quality here? It maintains a sorted order. The keys are in the sorted order. It does not allow null keys that we have seen. To use a custom class, what you should implement? The comparable interface, or we can provide comparator at the constructor. So let's quickly take an example. All these examples you try at your home also. If any doubts, we'll discuss it. So here what I'm doing, putting a map and the key is a product, name and price. Okay. Now I want to sort it based on, let's suppose I want to sort it. Here I'm implementing a comparable. Now I want to sort the products based on their price. Okay. So I'm putting 3 products here. Now I want to sort it based on the price. So which should come first? Which should come first? Tablet, then phone, then laptop. So the tablet should come first, then phone, and then the laptop. Why? Because in the product, we have specified a sorting by overriding compare to, and compared to what it is doing, it is comparing based on the price. And since we are using a product object as a key and our tree map, it maintains the sorting of the key. It is using that compare to function to sort the product keys into its map. What get will do? It will return a value, same, contains keys, same, iterator, entry set, and clear, everything is same as a hash map. Okay. Now concurrent hash map is the same as hash map, but why it is used? It is thread safe, right? It is used in a concurrent system. It allows multiple threads to read from the map concurrently and a limited number of threads which can modify it concurrently. It does not allow null keys or values. And if we try to insert any null keys or values, it will return null pointer exception. So please note this, it does not allow null keys or values, but others do. So if we iterate over concurrent hash map, it is weakly consistent. Why? Because there are lots of multiple threads which are modifying it. So let's suppose if some other thread has modified or added some map or added some values, it may be possible that the other thread who is parallelly iterating it may not see the latest value which is added by other threads. It will see it after some period of time. That's why we say it is weakly consistent. Again, if you want to use a custom class, you have to override the equals and hash code methods. Okay. So here, let's do an example. I think nothing is, everything is same as a hash map. It's just the name is different. Here, what we are doing, creating a concurrent hash map, putting a values. Will it preserve a insertion order or sorting? Will it? Yes or no? It won't, right? Because tree map maintains sorting and linked list maintains the ordering. Since the difference between hash map and concurrent hash map is just, it is a thread safe, that's all. Rest all function is same. Contains key, gate, remove, iterating through a map, clearing it, and everything is same. Okay, so there is no other difference other than it is thread safe. So that was about the map interface. We like, even though it is not there, the queue interface, I want to cover it. Should we cover it, or I think how many top? I think I have this queue interface left and 3 topics are also left. I always think I will cover it in one class, but tomorrow? It's late, right? Or okay, tomorrow we can cover. It will take time. Tomorrow, so I need to go to office. So evening, you all can come. Same 4 is there. You all can come evening. Okay, same time 5. Again. Okay, great. So yeah, that's all for today's class. Thank you.